Today we're going to talk about the law of sines, but first we're going to do a little bit of review of right triangle trig. So I want to find the value of the variable here, and we're going to round it to 2 decimal places. So I've got an angle here, and across the triangle, that's my opposite, and 11.72, that is the hypotenuse, which means I'm going to use sine. So it's sine 31 degrees equals the opposite over the hypotenuse. Okay, when we have the variable in the numerator, we're just going to take this number and multiply it across. So A equals 11.72 times sine 31 degrees. Okay, so we're going to check our mode here, make sure that we're in degrees. And then we can type in 11.72 times sine 31. And we get 6.036, so rounded to the nearest 2 decimal places, we get 6.04. Okay, so here we've got our angle here. This is the adjacent side and the hypotenuse. Adjacent and hypotenuse is cosine. Cosine 63 degrees equals the adjacent over the hypotenuse. Okay, now this time we've got the variable in the denominator, so we are going to switch these, and then we'll divide. So phi equals 4.83 over cosine 63. And that's 10.638, so 10.64. Can we use the same types of trig functions to find the length of k here? So first, I need to know what is this angle measure right here. So triangle is 180 degrees. Take away 38 and 64, and we get 78 degrees, which means this is not a right triangle. So the answer is no, because trigonometric functions require right triangles, and that is not a right triangle. That is an oblique triangle, which is any triangle with no right angles. Okay, so in an oblique triangle, we can't just use sine, cosine, and tangent, but one thing that we can use is the law of sines. Okay, so here is the law of sines. A side over the sine of its opposite angle equals another side over the sine of its opposite angle equals another side over the sine of its opposite angle, or the reciprocal. In this case, those capital letters, those are angle measures. The lowercase letters are side lengths. Okay? And that can be used anytime we are given angle, angle, side, or angle, side, angle, which really, what that's telling us is that we've got to have 2 angles and 1 side. Okay? Anytime we've got 2 angles and 1 side, we can use the law of sines. So for triangle ABC, we're going to draw that. Angle B is 64 degrees. Angle C is 38 degrees. And side B is 9 feet. We want to find the measures of all the sides and angles. So we've got angle A over here, which means across from that is going to be side A. Angle C across from that is side C. I need to find those 2 side lengths and that angle measure. Okay, to get the measure of angle A, that's going to be the easiest part. I just have to do 180 minus the two angles that I know. And that's 78. So that's the measure of angle A. So I'm going to write that into the picture also. So now I need the length of side A and side C. So we'll do side A first. So A over the sine of the opposite angle equals any other side over the sine of its opposite angle. So we'll use 9 over sine 64. Okay? So to get A by itself, all I have to do is multiply both sides by sine 78. So I'm going to multiply this up to here. So it's 9 times sine 78 divided by sine 64. 9.79. Okay? Now, I could use this 9.79 over sine 78 in my calculation to find C, but since I had to round this number, we're going to get more accurate results if we don't use this rounded number in any future calculations. There will be times when we have to, but whenever we can avoid using a rounded number to do a further calculation, we're going to go ahead and avoid that. So we're going to do C over sine 38 equals, so instead of doing 9.79 over sine 78, I'm going to use a number that I know is exact, 9 over sine 64. .79 over sine 78 would probably give me the same answer rounded to 2 decimal places, so it's really a matter of how precise we have to be. If you're doing calculations that require a very high degree of precision, using a rounded number is not a good idea. So I'm going to multiply this across, so I get 9 times sine 38 divided by sine 64. So I get 6.16 for C. And that is in feet. So I really should have feet here for A also. Okay, example 2, triangle FGH. G is 58 degrees. H is 42 degrees. F is 10 meters. Find everything that's missing. So we'll start with angle F. 180 minus the two angles we know. Okay, so F is 80 degrees. Okay, so I still need to find G and H. So to do G, I would do G over sine of the opposite angle, 58 degrees, equals 10 over sine of 80 degrees. Okay, so I've got this sine 58 in a denominator. I want to multiply that across to the 10, so 10 sine 58 divided by sine 80, 8.61. And that is in meters. Okay, Then I can do h over sine 42 equals 10 over sine 80. Okay, so I need to multiply it across. 10 times sine of 42 divided by sine 80. 6.79. Okay, so here I want to find the measure of angle U, the length of side T, and the length of side S. So first, 180 minus 23 minus 72 is 85. That's the measure. Not really sure why I put an F there. Try that again. The measure of angle U. Okay, then I want S and T, so S over sine 23 equals 5 over sine 85. So I'm going to multiply that sine 23 across, so 5 times sine 23 divided by sine 85. 1.96. And that is in feet. And then T over sine 72 equals 5 over sine 85. Okay, so I'm going to multiply that sine 72 across. 5 sine 72 divided by sine 85. 4.77 feet. Some things to look out for that might help you know if your answers make sense. The largest angle should always be opposite the longest side. Smallest angle should always be opposite the shortest side. Your interior angles should always add up to 180 degrees. Okay, so if any of these conditions are not met, then your answer is probably not correct. An acute angle should always end up being bigger than 0 degrees, but smaller than 90 degrees. An obtuse angle should always be bigger than 90 degrees, but smaller than 180 degrees. You can't have more than one obtuse angle in a triangle. And if you do have an obtuse angle, or if you have a right angle, it must be the largest angle. Okay, so if you have one obtuse angle and then you find another angle and it's even bigger, that's going to be a problem. So you should only have one obtuse angle. If you have a right angle, you can't have an obtuse angle. So 90 degrees or bigger, that must be the largest angle in your triangle.